Hello there, developers, and welcome to day 2 of the ROS2 Learning Week. So, welcome everybody, and today we are going to focus on learning from scratch Python. So, we are going to be creating some Python programs starting from very basic, and we are going to build on that. So, let's not lose any more time and let's go for it. Alright, so welcome everybody to this day 2 of the ROS2 Learning Week. I hope you enjoyed it yesterday. We had some issues at the beginning of the class which have been solved for today, so everything is going to work properly today. And as I was saying at the beginning, today we are going to focus on learning some Python programming. Since we are going to be doing the ROS2 part, we are going to be learning ROS2 based on Python. So that's why today we are going to start learning some basic concepts that we need to know in order to be able to learn ROS2 with Python. So that's the main goal for today. Then let me not lose any more time talking, and I'm going to switch directly to my computer screen. So let me come here. There we go. Okay, so here I am in the main panel again. So we are going to be working today also with a course, just as we did yesterday. I already explained this yesterday, but I'm going to explain it again. So basically the procedure for today is that we have the main panel here, where you are going to be able to visualize and listen to the stream, as you can see here. By the way, remember that you can tune the volume here in case you want to increase it, decrease it, whatever. And then we are going to open another page, a new tab. Let me do it right here, where we are going to launch the course that we are going to be following. So in this case, the course that we are going to be working today is the Python3 for robotics. All right. So in order to reach this course, you can come here to the courses page in the left menu. You can search it directly here if you want. You are going to find it here. Or you can just filter here for the basic ROS category, and then you're going to find it right here. So yesterday we were doing the Linux for robotics, and today we are going to start with the Python3 for robotics. As you can see, it's free, so you're going to be able to launch it without any issue. And of course, after the live class, sorry, not the live class, but after today's class, since we are not going to be able to finish the whole course because there's too much material, you can continue at your own pace doing the course, exercises. You can continue today after the class, or even if you want tomorrow, you can continue with the course in order to finish it. All right. So let's right now already start the course. We are going to click here in the Start Learning, and this is going to load the environment. So all right, so here the environment is loading. It might take some extra minutes, and since there is lots of people connecting right now and launching the course, so just be patient. It might take some minutes, but it should load properly. All right. In case that you are having some issue here loading the course or whatever, just let me know in the chat, and I will be checking it. So let me check here so far how things are doing. So any doubt so far? Do you have clear the procedure, the setup that you need to have? So let me remember. We are going to be here in one tab of the browser. We are going to have the main panel here of the ROS2 Learning Week with the streaming and the chat. So that you can type anything here in case you have doubts or whatever. And then in a different tab, we are going to access the Python course and load it. All right. So far, so good. I can see many people here. Hello from Barcelona, from Germany, from Brazil, from Ecuador. So it looks like this is a quite international class. Also, I can see that most of the people here right now writing in the chat has images. For the ones that you don't have images, I really encourage you to do it. It's super, super simple. You just have to come here to the bottom right corner of your screen, and then you can click on the profile, and this is going to load your profile page. So here you can update your profile. You can very easily update your image here. And if you feel so, if you want, you can also fill in your ROS portfolio with your work experience, and you are going to gain the chance of being hired by ROS companies that are interested in any ROS developer. So go ahead, have a look, and fill it. But at least I would really appreciate that you at least update your image, because this is going to make the chat experience and everything much more personal. Because otherwise I feel like I am talking with bots or something. But if I see an image there, it's much more personal and everything, and the experience it's much more grateful and fluent for me. Hello from England, Colombia, Nigeria. Jesus Christ, yeah, this is like a super, super international class. How to get the Python course is asking Jay Graham very, very easily. You just need to come here. Oh, actually I can show it here. So you just need to come here. If you click here in the left side of the page, the main menu is going to hover. You are going to see it here. So you can come to the courses. You can click on the courses button. Then this is going to show you all the courses available. There are lots of them. You can check them in case you are interested in any particular topic or subject. And you can scroll down here and you are going to find it here in the basic ROS section, or you can just directly filter here in the categories and select the basic ROS category, and you are going to find it right here, Python3 for robotics. All right. Let me actually write it here in the chat so that it's super clear. Python3 for robotics. There we go. Nice, nice, nice. I can see that almost everybody here in the chat has updated his image, which I really thank you a lot. All right, so once you have loaded the course, you should be in a screen like this. All right, so you are going to find here in the left side the notebook, which probably you are going to start in the chapter number 1. So let me come here myself as well. Then here in the left side, you are going to find the notebook, which basically is going to contain all the instructions that we are going to be following. So in case you miss something, you can just read here to make sure that you are on the right point. As you can see here, you are going to find all the theory, all the explanations, and also exercises to do, etc. Then here, at the top middle part, you are going to find the IDE, which is going to allow us to work in a graphical way, creating files, creating folders, editing file, generating code, etc., etc., in a graphical way, which is always much more easy to work with. Then down here, you are going to find the shells, which basically are Linux shells. You are going to find 4 of them, in case we need to use more than one at some point. And finally, here in the top right corner, you have the gazebo simulation. All right, so basically the programs that we are going to be doing in Python are going to interact in some way with the simulated environment, with the robots that we have here. So in this case, let me try to, there we go. So in this case here in the unit 1, you are going to find a robotic arm, a universal robot here. But I want to make clear this, so that the Python programs that we are going to be creating, even if they are quite simple, the goal is to make them interact in some way with the environment. All right, for some examples, this is not going to be applicable because they are going to be very, very basic. But at some point, we're going to create programs in order to interact with the robots in the simulated environment. All right, so let me know, please, in the chat if everybody is here, if everybody is ready to start with the class, or if you are having any kind of problem. I read you here in the chat. Yes, yes, ready. Yes. Okay, so it looks like we are ready to start. Then the simulation is stuck loading for 5 minutes. I understand that, Graham. Okay, you can try. I understand that this here is not loading for you. So maybe you could wait 1 or 2 extra minutes to see if it loads. In case it doesn't load, you can try maybe refreshing the page, because maybe there's some kind of book rendering the simulation. And if that doesn't work, you can also try clicking here on the third button, which says reload the simulation and restart the entire simulation. All right, not the first one, not the second one, but the third one. If you click here, actually I'm going to do it right now. So in case you have some problems in the simulation, you can click on this button, which is going to load the simulation again. All right, it's going to launch the whole system again. And in theory, in a few seconds, you should have the simulation running. All right, so it could happen sometimes. Gazebo simulations have some bugs, so it shouldn't happen, but it can happen that in some cases the simulation, for whatever reason, it doesn't load. So if that's the case, proceed like this. So if you see that it's not responding after 5 minutes or something like that, then just try to click here in the reload the simulation button. All right. So let me have a last look here at the chat. Hello, Dado Hacker. Hello. Refresh worked for me. Nice. So Duck Frost says that refreshing the browser worked for him. Hi guys, will there be a video appearing on the screen where there is the date and time of the lecture? Will there be a video appearing on the screen? I don't quite get your question, Antfur. What do you mean? What video are you talking about? Sorry, until I didn't reload the page, the video did not appear. Okay. Yeah, as Ricardo is saying, the video will be published in YouTube. All right. So when right after this class finishes, which is going to be around 30 minutes past 7 and 8, around there is going to finish the live class. So as soon as the live class finishes, we are going to upload the recording of the class to YouTube. All right. So in case someone, for whatever the reason, cannot be here during this time or has to leave, don't worry, because you will have the recorded video in YouTube right after the class finishes. All right, then let's go for it. So let me go for it. Then, so today we are going to go with Python3. So here you have probably appeared in this Unit 1, Introduction to the Course. However, we are going to skip this unit because basically it's just introducing the course and whatever. So I'm going to go straight to the meat in this case. Then what I'm going to do is to move directly to Unit 2, Python Essential. So we are going to start from here. And we are going to start from the very, very basic of Python, all right? So don't worry if you don't have any background in Python. Don't worry, because we are going to start from the basics, all right? In some cases, I'm going to go a little bit fast for time issues, because the time we have is limited and I would like to cover as much as possible. So there are some things that maybe I'm going to go over over them too fast. So if that's the case, don't worry, because you can always reread the notebook in order to get extra information about any topic. You can revisit the course later after the class finishes in order to get better knowledge, all right? But the thing is that if I explain everything in detail, then we wouldn't have time to do much. So in some cases, just keep in mind this, all right? So don't panic, and just keep in mind that you can always read the notebook or revisit the course after the class finishes in order to understand something that you are missing, all right? So yeah, let's go for it. Then, actually, okay, let me see one thing, because I'm not sure right now if we need to download a repository for this course. I don't think we need to, but let me have a quick look here. Yeah, we don't need to. So, all right, yeah, so no issues. We can start from Unit 2 and build from there. Okay, so let me move back to Unit 2. Thing is that I have lots of files here because I have already visited this course before, of course. In your case, probably you are going to have this empty. Don't worry, that's normal. I have all these files because I have been working previously many times on this course and doing tests and many things. So that's why I have all these files here. In fact, I'm going to clean a little bit this so that it's not that of a mess. So let me download all the, for instance, I'm going to remove the Linux core files. Let me see what I have here. I'm going to remove also this robot control folder. All right. So, yeah, let's go for it. So, first of all, we are going to start doing an exercise, which is this exercise 2.1, which is going to help us understand a little bit what our data types and variables are. As you can see, these are very basic concepts. Most of you probably already know what data types are and variables. However, we are going to do this exercise real quick because it's going to help us set up a little bit everything for the rest of the course, all right? So, first of all, we are going to be executing these commands in the shell. So what I suggest is that you copy directly the commands. When you find commands like this one, like this in the notebook, you can copy them automatically here from the notebook and pass them here to the shell, all right? This is going to save you a lot of time instead of having to write everything. So I recommend, I suggest that you use this copy and paste method in order to speed up things. So first of all, what we are going to do is to come here to the Catkin workspace src directory. As you can see here, we are starting using cd commands, mkdir commands, touch commands. All these commands, we already reviewed them in yesterday's class, in the Linux class. So I'm going to avoid explaining all of this, all right? So yeah, first thing we are going to do is to come here to the Catkin workspace src folder, and we are going to create a folder named robot control, all right? So let me do this. This is going to generate a folder, in your case here, which is going to be empty, named robot control, all right? You are going to be able to see it here through the shell, for instance, with an ls command. Here you have it, robot control, and also, of course, in the IDE, all right? So now we are going to go inside the robot control folder, and we are going to create here a new file, a new Python file in this case. So we are going to run this command, touch pyscript1.py. Okay, as you can see, this has generated this Python file here inside the robot control folder. All right, you can also see it here. And in this case, this file is empty. Of course, we have just created it. Then we are going to also create another file named robotcontrolclass.py. So let me copy and paste the command here, and there we go. All right. So now we are going to paste the code shown here in the notebook into these scripts. All right. So first of all, let me open this robot control class.py. Here we have it, which is empty, of course. So now we are going to fill it with this code here. So I'm going to come to a notebook and select all the code that we have here, all. There we go. I have selected the whole code here. So I'm going to, okay, it doesn't allow me to copy it for some reason. Let me reselect it again and copy it directly with Control-C. There we go. Copy it, and then I'm going to paste it here to the file. There we go. All right. So here I have my Python code in the empty file that I have just created. All right. Here I have it. Don't worry about all this code. Okay, you don't need to understand it. This is a step that we are doing for setting up some things of the course. All right. So don't worry if you see this code and you get overwhelmed because you don't understand it. Don't worry, it's not the purpose to understand this code at this point. All right, so don't worry, just copy and paste the code here. And now we are going to do the same with the other empty file that we created, PyScript1. So let me come here to PyScript1 and I'm going to copy and paste this code here. Right, so let me copy it and paste it here. There we go. Okay, so at this point, you should have in your King workspace src folder, you should have this robot control folder with two files inside it. One is named robot control class.py and contains this very big code here, which we don't need to understand right now, and the other file, which is this PyScript1, which contains this simpler code. All right? So far, so good. Let me know, how are you doing? Are you following until this point? How to paste? You can paste. Let me see if it allows to paste. It doesn't allow like this. Okay, so you have to paste here with Control-B. All right. So if you have to use the shortcut to paste, which is, let me write it here. Control must be Control plus the key V. All right. So this shortcut is going to allow you to paste things into the IDE. Yes, yes, yes. Okay, so I understand that you are following. So far, so good. Going good. Great. All right. So we are going to proceed right now to execute our first Python script, this PyScript1.py. So being here in the robot control folder, where we have our two Python scripts, we are going to run this command here. Python PyScript1.py. Okay? And this is going to give us the following output. Okay? So right now we have executed our first Python program, our first Python script. So the first thing you can learn from here is that in order to run Python scripts, you can use the Python keyword. Okay? This Python keyword is going to allow you to execute Python scripts. All right. Then, what is going on inside the code? Okay, you have the explanation of the code, of this basic code here, more in detail. But summarizing, we are doing some different things here. Okay. At this point, some of these things might be a bit complicated, but don't worry. For now, let's just focus on the variables, okay? So here in the first line, what we are doing is to import. Okay, as the keyword says, we are importing this robot control from a place. Okay, so one thing that Python has is that it's very easy to understand the code. It's quite easy to understand. So if you read a C++ code, it's much more complicated to understand. But Python, it's very intuitive in the way it's programmed, right? So in this first line, what we are doing is to import this robot control thing. And what is this robot control thing? This is a Python class, okay? And we are importing this from this robot control class. Does this resemble to something? Does this look similar to something? This robot underscore control underscore class? Does it remind you to something? Gazebo is loading ARM instead of Turtlebot. That is probably because you are in Unit 1. You have to move to Unit 2, Python Essential. Okay, Python Essential, Unit 2. Okay, so this robot control class looks suspiciously similar to the other script that we have inside our robot control folder, right? This other script, it's named robot underscore control underscore class, right? So basically what we are doing here is that we are importing from this file, from this Python script, we are importing this robot control. See? So from this robot underscore control underscore class dot py script, yeah, we are importing robot control, which is this. It's this class. And what has this class contain? This class contains many functions that we are not going to analyze that are going to allow us to interact with the simulation. Okay? All these functions that we have here, all this code that we have inside here, basically is going to allow us to interact with the simulation. Okay? But as I was saying before, you don't need to worry about this code. Just keep in mind that this code is going to allow you to interact and to communicate with the simulated robot and the simulated environment. All right? So we are going to be importing this class in most of the programs that we create, at least when we want to interact with the simulation. All right? Okay, so we are, first of all, importing this class. Then we are creating an instance of this class. Okay? We are creating an instance because we are going to be working with these functions. And we are storing this in a variable which is named RC. Okay? First thing that you can see here is that in Python you don't need to specify the type of the variable. Okay? You can directly write the name of the variable and assign something to it. Okay? So in this case, in this RC variable, we are saving an instance of this class. Okay? All these words that I am using, instance, class, don't worry, because they are going to be clear here in Unit 5, where we are going to address specifically this topic, Python classes and object-oriented programming, okay? So far, just get familiar with these words. Then here we are creating another variable named A, and we are assigning some value to this variable. In this case, the value that we are assigning is going to come from the getLaser function of the RC class. Okay? So if I come to this class, I'm going to see that there is a function somewhere here. Here I have it, getLaser. Okay? So what I am doing here is to call this function. And this function, basically, we are not going to analyze it right now, as I was saying, but this function, basically, what it's going to do is that it's going to return a value of the laser readings. In this case, it's going to return us the value of the laser readings that are pointing to the front of the robot. All right. So here, right here, we have the front of the robot. Right here. So basically, here we have the laser mounted, and this laser, as you know, has beams. Okay, I don't know if you have, yeah. So a laser basically is sending many beams to the space. So you can see here. In this case, it's covering 180 degrees. Okay, and then some laser beams are going to point to the left area. Some of them are going to be pointing to the right area, and some of them are pointing to the front of the robot. Okay. In this case, as you can see here in this image, the laser beam number 360 is pointing right in front of the robot. So basically what I am doing here is to get the value of this laser beam which is pointing in front of the robot. Okay? And then I am storing this value into a variable named A. All right? Then finally here what I am doing is to print this value. All right? So this is basically what we can see here. Yeah? We can see here that we are printing this sentence, the distance measured is, and then we print the value of the A variable. So the distance measured is, in this case, 2.49 meters. All right? Which is telling me that in front of the robot we have this wall, which is at 2.5 meters. All right? So what can we get from here? We can get from here that variables are probably the most basic element in Python programming and in most of the programming languages, all right? And these variables are going to be used in order to store information, to store data, all right? And in Python, it's not required to specify the type of the variable, okay? It doesn't matter, it's not required. Yeah? As you can see here, you have much more detailed information, which we are not going to cover right now. You can come back here later if you want. So here you have some very, very basic examples that you can also create in order to test. All right. So you can come here to the SRC. Actually, are we able here to? Oh yeah, here we are able to run them directly on the notebook. Okay, so yeah, basically here in the notebook down below you have some super basic examples. So for instance, here we are declaring a variable which is named A, and we are saving the number 5 into this variable. Then later we are changing the value of the variable A into 6, and finally we are printing it. So at the end, we are going to get the value 6, of course. Yeah, makes sense? We have some other examples here. For instance, here we are declaring the number 5 and saving it into the A variable, and later I'm modifying it, and I'm saving now a string, a sentence, yeah? So this can be done also without any problem. If you run, you can run these pieces of code, by the way, by clicking here in this play button that you can see here in the notebook, okay? This play button is going to execute this code. There you go, all right? So as you can see, we can change on the fly the type of a variable. In this case here, we are changing it from an integer to a string on the fly, yeah? Many more things. Here we have here we have an exercise, a quite simple exercise. So let's do it. Why not? Let's do it. So let's create this a new file inside the robot control folder. We are going to create a new file. Okay. Again, you can create the file if you want here with the touch command from the shell, or you can also create it directly from the IDE by right-clicking on the folder and then click on New File. So this way you can also create files. In this case, I'm going to create now which is, a new one which is named variables.py. There we go. Then right now is empty, so in this case I'm going to go straight to the solution. I'm going to copy and paste the solution, right? Directly like this, okay? So that we don't lose time solving it and everything. So basically here it's asking, this exercise is asking, you will call the function getLaser with any number and store its response into a variable named laser1. Second, you will print this value in order to see what you get. Next, you will call the getLaser function again with a different number and you will store its response in another variable named laser2. Then again, you will print this value in order to see what you get now. And finally, we are going to call the getLaser function. One second. All right, so, and finally, we are going to call the getLaser function a third time with a different number, and we are going to store the value in the variable laser2, and we are going to print again the value of this laser2 variable. All right, so basically, this is what it's done here. So let's quickly review it. First of all, of course, we need to import our class so that we are able to call the functions of this class like the getLaser functions. Yeah, this getLaser functions, as I was saying before, is contained inside this class, so we need to import it, okay? Then we also, if we want to use a function of this class, we need to, first of all, create an instance of this class. Yeah, this is always required, okay? So every time that we are going to interact with this class, we are going to have to do at least these two things. First of all, import the class, and next create an instance of the class. And then I am saving this instance into this variable, which I am going to use later to call the functions of the class. All right? So once I have done the setup here, then I am defining the laser1 value, and I am storing the laser beam 0, the data from the laser beam 0 in this case. Then I am defining the variable laser2, and I am storing the data from the laser beam number 360. And then I am overwriting the laser2 variable that I created previously, and I am saving, in this case, the data from the laser beam number 719. And in every case, I am printing this value so that I can monitor it. All right? So what I would expect if I run this code is that I get one random value printed first, in this case the laser beam number 0, then I'm going to print the laser beam number 360, which is in front, and finally I'm going to print the number, the laser beam 719, which is going to be overwriting this laser2 variable. Okay? So let me run this code then. Here, Python variables.py. And there we go. Okay, so we get the first laser, which is inf, the second one, which is 2.5 meters, and the third one, which is inf. So, does this make sense? What do you say? These values that I am getting, taking into account this image that we have here in the notebook, which all the laser beams and each position, 360, 0 here in the right side, and 719 here in the right side. So does this answer make sense? What do you say? Let me know here in the chat. Does it make sense? What does inf represent? Very good question. Very good question, Krishna. Inf means infinite. Okay? So this stands for infinite. What does this mean? This means that the laser is reaching its maximum value without colliding with anything. Okay? So a laser beam, when it collides with something, it's going to return to the base, and it's going to provide the distance from the laser to that obstacle, right? That's why here in the middle, which is the laser 360, which is the middle, I'm getting 2.5 because I am detecting this wall, which is 2.5 meters from the robot. However, if the laser doesn't find any obstacle in its way and it reaches its maximum range without colliding with anything, then it's going to return the infinite value. Okay, there we go. Yeah, I can see that you have answered yourselves already. So yeah, great. I can see that there are some issues here with J. Graham. I can see that Miguel is helping you. So okay, so let's keep advancing here. Then, data types. Okay, so which are the most common data types that you are going to be working with in Python? Basically, they are numbers, okay, which they can be integers and floats. Integers are number like these ones, 1, 2, 3, 4, 5, 6, 7, and floats basically are decimal numbers, okay? 0.5, 1.2, 3.7, whatever, okay? And the second data type are strings, which basically are series of characters, like this. Yeah? We also have the lists, which are basically lists of things, okay? So we can create a list like this, which is going to contain different subvariables, let's say, inside it, okay? It can contain integers, as you can see, floats, strings, etc. Okay? The fourth one are tuples, which basically are very similar to lists. We will see it in a moment. And finally, we have dictionaries, which also are similar to lists, but every item in the list, it has an associated key. Okay? So for instance, the first item, which is in this case 25, it has an associated key, which is John in this case. So in order to access this 25 value of the dictionary, I have to provide the key of this value. All right? So let's see some very simple examples here. Let's start with so integers and floats are super simple, so I'm going to skip them. Strings also are super simple. Just keep in mind that you can print, for instance here, you can print only one of the characters of the string, of the string. So for instance, if I print from the S1 string the character 0, I'm going to print only the letter T. And from the S2 string, I print the character 8, then I'm going to print the character 0, 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to print the character A. Okay? So if we run it, we can see this very clear here. Okay? Just so that you have in mind. Also, it's possible to concatenate strings. Okay? If you have one string in the variable S1 and another string in the variable S2, you can concatenate them. And this is going to result in a new string, which is going to contain this is a string. Yeah, so in this case, we have S1, S2, which we are concatenating here into the S3 variable. So if we print the S3 variable, we are going to get the sum of the two strings. All right? Okay, so some more things here. Lists. So for instance, we can print, again, a whole list, okay? Like we are doing here. Let me execute it. and we are going to get all the items of the list, okay? But also we can access only specific values of the list, like this, okay? In this case, we are getting the value 2, which is, what is the value? So here, if I am accessing the position 2 of the list, what I am going to be printing? The number 2? Will I be printing the number 2? What do you say? It's the second position, right? Let me know here in the chat. Three, it starts with 0, no 3. Very well, very well. Okay. I see that I was trying to trick you here, but you didn't fall in the trick. Very well, very well. That's right. No, it's going to be printing the number 3 because the position counting starts with 0. So the number 1 is the position 0, number 2 is the position 1, and number 3 is the position 2. So very well, you didn't fall in my trick. Okay, and also as you can see here, we can print from one position to another position. For instance, here we are going to be printing the list from the position 0 until the position 3, which is this one, or from the position 3 until the end. Okay, so we can do these kind of things, when working with lists. Okay, so just keep this in mind. Let me execute this so that you can see the different results. All right. What else? Okay, here I'm just combining things. Okay, so tuples, as I was saying before, basically are like lists. It's the same as a list, but they are read-only. Okay? So the values inside a tuple cannot be updated or modified. Okay? So in a list, we can, as you can see here, we can modify certain values inside the list. In tuples, we cannot do this. So basically they are the same, but tuples are read-only. They cannot be modified, the values inside a tuple. And the difference is that tuples are defined with parentheses. See, like you see here, tuples are defined inside parentheses, and lists are defined inside brackets. Okay, this is the difference on creating in code a list or a tuple. And finally, you have the dictionaries. Okay, dictionaries are defined with these. I don't know how to call it right now, with these special brackets. Okay, and basically, as you can see, it's quite simple. Let me make this a bit bigger, in fact, so that we can see it better, much better now. So dictionaries, again, are similar to a list in the sense that you can store different values inside it, but every value that you store inside a dictionary is going to have an associated key, as you can see. So this value has the John associated key. This value has the Daenerys associated key, and so on. Okay? So, for instance, if I want to print this value, I'm going to access to this value using its key, as you can see here. Okay? So this print is going to print the number 25, and this second print is going to print the value 35. Okay? Let me run it, and you are going to get the result right here in the notebook. All right? Very well. So let's see what we have here. Okay. Yeah, so let's do this first exercise for now. So we are going to create a new Python script which is named lists.py. So let me minimize this back again. I'm going to create my new script, lists.py. All right. And I'm going to, again, copy the code directly from the solution to here. So basically what this exercise asks is that we have to call the getLaserFull function, okay? This is a new function, as you can see, okay? This is not the same function as that we have been using until now, which is getLaser. In this case, we are using the getLaserFull, okay? And what does this function do? We have it here. So as the name itself says, this function is going to allow you to get all the data from all the laser beams of the robot, okay? So with the getLaser function, we can access one specific beam. We can get the data, the reading from one specific laser beam. With the getLaserFull, we are going to get all the data from all the laser beams, okay? From the laser beam 0 to the laser beam 719, which is the last one, okay? And all these values are going to be then stored into what? Into a list. We are going to have this variable L, which is a list, which is going to contain all the values, okay? Then what else it says? Then you will print the positions 0, 360, and 719 from the full list of readings. All right, so now that we have in this variable L the whole list of laser readings, then in order to print them, we are going to access specific values inside the list. In this case, we are accessing the first one, which is the position 0, the laser beam from the middle, which is 360, and the last one, which is 719. All right? So, if I print this, what should I get? What output I'm going to get? If I am printing the first value, which corresponds to the left of the robot, then I'm printing the value 360, which corresponds to the front of the robot, and finally I am printing the value 719, which corresponds to the right side of the robot. What I'm going to get? Does somebody know? Curly brackets, that's it. Thank you very much, Schmalinger. Yeah, those are curly brackets, yeah. Does cut and paste with Control C and Control V work in the term with V? Yeah, it should work. Let me test it right now. Let me see the answers. Infinite 2.5 infinite, infinite 2.5 infinite. Very well, you are right. So let me run it very quickly here. Python list.py. So there we go. Infinite 2.48, more or less 2.5, and infinite. Very well. Okay, so Graham was asking about this, so let me do one thing. I'm going to remove this list.py. I'm going to create it from 0, touch list.py, and then I'm going to copy the code here with Control C from the notebook. Then I'm going to access with B my script. Let me make this bigger so you can see it better. Clear, there we go. ls, okay, B, list.py. Okay, now I trigger the insert mode as we saw yesterday. I trigger the insert mode, I press Control V, and it gets copied. So yes, it should work, okay? So once you copy the code, remember to press the ESC key and then 2 points WQ in order to save the file, okay? And then I have this lists file created again here with the code and everything. So yeah, it works with V. Control C, Control V. Same like before. Okay, very well, very well. I see that you are getting things fast. So maybe I'm going to speed up a little bit everything. All right, so print functions, input and output functions, very simple. We can use print in order to print something to the shell, as we have been seeing here. And we have also the input. So we can use input in order to get input from the user, okay? So for instance, let's create this script. Here I'm going to name it input.py, okay? And I'm going to copy and paste the code from here to here and save, okay? So basically I'm using the input function in order to capture something from the user, and I'm saving this into a variable named name, okay? And then I'm going to print the value of this variable. So if I run this program, let me run it, Python input.py. The program is asking me, hey, what's your name? As we can see here. Yeah, what's your name? So I'm going to answer Alberto. And then the program returns me, nice to meet you, Alberto. Okay? So as you can see, the input function can be used in order to get data from the user. All right? So let's keep moving on. I'm going to escape all these examples. You can do them by your own if you want. But I see that you are smart guys, so I'm going to speed up things. Okay, finally we have operators, which is something very important also. But it is something that is used also in other programming languages, so maybe you already know about them. But basically the most important ones are this one. So we have the addition operator, the subtraction operator, the multiplication, division, and modulus. All right? So here we can see some examples, some very basic examples. So having a variable a, which is 5, and having a variable b, which is 2, we can add them, which is going to result in, let me run this piece of code. If we add them, of course, it's going to result in 7. If we subtract them, it's going to result in 3. Yeah. If we multiply them, it's going to result in 10. If we divide them, it's going to result in 2. Okay? Because the division operator doesn't give us the rest of the division. Okay? So 5 divided by 2, it's 2.5, right? However, if we use the division operator, this is not going to give us it's going to give us only the integer value, all right? It's not going to return the a float value, right? And the modulus basically returns the rest, yeah? So since 5 divided into 2, it's giving us 2. The rest of this division is 1, yeah? So basically, these are the most common operators. You can check them here, test, whatever. We have also the assignment operators. All right. So we have this operator, which basically is going to assign a value. See? We have this other operator, which basically sums and assigns. We have the minus equal, which is going to subtract. Sorry, I wasn't getting the word. It's going to subtract and add. Then this is going to multiply and add, divide and add, and calculate the module and add. Okay. So for instance, if we run this piece of code, we have x. Okay. Then if we do x plus equal 1, basically this is going to add 1 to the previous value of x, which was 5. So I am getting 6 as a result. Okay? So now my variable x has the value of 6, right? After this. Then if I subtract and add 2, basically this is going to subtract the integer 2 to my current value of x. So if my current value of x is 6 minus 2, I'm going to get 4. Okay? And so on. All right. Then we have the comparison operators. Okay? The equal means equal. Okay? So we are going to use here the if statement, which we are going to see in the next unit. But basically this operator, equal, is going to compare both of them. Yes? If A is equal to B, then this is going to return, this operation is going to return 1. If A is not equal to B, well, actually, it's 1, but if A is equal to B, this operation is going to return true, let's say, okay? And if A is not equal, so this condition is not met, if A is not equal to B, then this operation is going to return 0. All right? And the same happens with the rest. So we have the exclamation equal, which basically is the opposite as this one. Yeah, so this, if I change it here, this means that A is not equal to B. So if A is not equal to B, this operation is going to return true. And in this case, if A is equal to B, this operation is going to return 0 or false. Yeah, makes sense? Then the same logic applies here. So if A is higher, is bigger, is greater than B, this operation is going to return 1. If A is lower than B, this operation is going to return 0. Yeah, we have the lower than, we have the greater or equal than, and we have the lower or equal to. Okay? So these are the comparison operators, the most common comparison operators. Okay? You can run the code here to see how this affects and operates. Okay? And that's it. Final thing, we have the comments in Python. Okay? So if you want to add comments to the code, you have to use this asterisk. Okay? And this adds a comment to your code. Okay? Comments are going to be useful. Let me use one here. For instance, print the result. Okay? On here, get input from the user. Okay? So comments in code are going to be usually used in order to make your code much more easy to understand. All right? So for developers, but specifically with ROS developers, there is a lot of share of code. Yeah, so very often you are going to use code which has been developed by other person, ROS packages that have been developed by other person, and if you have to go inside the code and check it, it's always very nice to find comments that are going to help you understand better the code that they have created. Okay, so this is the main purpose of comments. All right, so let me, so that's it. Then let's move to next unit. So let me move to unit 3, conditional statements and loops. There we go. Okay, so far so good. Are you following the class well? Yeah, do you think it's a good pace? How is inf used in compare as a string? Yeah, exactly. Yes, good, very well. Absolutely. Yes. Okay, very well. So let's continue with conditional statements and loops. With this, it's something super important also. Okay, so let's go for it. Then, okay, so far we have defined already some very basic concepts on Python, But in order to build more complex Python programs, we are going to need to use conditional statements, okay? And what are conditional statements? Conditional statements are going to allow us to decide depending on the previous code, okay? So basically, we are going to have to make decisions in our code depending on the value of variables, okay? Then, let's imagine one scenario, for instance. Let's imagine this scenario here, okay? So, we can make our robot, our specific robot, work under some logic. We want our robot to follow some specific logic or behavior. Then, for instance, this is a possible behavior. So, is there a wall less than 1 meter in front of the robot? And then we evaluate this condition. If the answer is yes, then we stop the robot, because we don't want the robot to crash with the wall. If the answer is no, then we keep moving, because there is no obstacle right in front of the robot. Makes sense? And this is a very simple condition, but this can be applied to almost everything, okay? So we can evaluate the environment and we can evaluate most of the things using conditional statements. Much more complex, combining conditional statements, etc., okay? And this is one of the most important things in programming and also in C++. So this is something super basic and super important, conditional statements, okay? Then this very simple behavior and logic could be used in code, in Python code, with something like this. If wall is closed, then stop the robot. Else, so if this condition is not true, yeah? So this would be the if statement. If yes, then we go inside the statement, as you can see. And we execute whatever we have inside this if statement. If the answer is no, then we go inside the else. And we do whatever, okay? And then we can come back to a common place again and print. Yeah, so in both of the cases, if you enter the if or if you enter the else, at the end you're going to print the reading, okay? Then it's very important also to keep in mind this indentation, okay? So I know that this stop robot function here is inside the if statement because of this indentation. Yeah, this is super important, okay? If I move this here, this completely changes the program. Yeah, so now the program is going to be completely different than if I do this. Okay, so indentation in Python is super important. All right, and you can create programs that apparently they are correct, but because of indentation they are not working as expected. Okay, so this is something super important. Yeah. Then inside the if condition, we can place as many statements as we want. So if a certain condition is met, then we can do this, and we can then do this other thing and these other things. Okay. Then we have the else. So if this condition is not met, then we are not going to enter anything of this code. We are going to skip this code, and we are going to jump directly to the else statement and go inside this. And then we are going to start executing the statements that are inside the else. Okay? For instance, let's create well, actually, let me skip these ones, which are very simple. And let me move and introduce another statement, which is elif. Okay? So we can evaluate multiple conditions. If condition 1 is met, is true, then we are going to do this. And then also I want to evaluate another condition, okay? Then if also this condition is met, then I'm going to do this condition, okay? So actually, the thing is that if this condition is not met, then I'm not going to jump straight to the else, but I am going to jump to the next condition, and so on. I can place as many conditions, as many extra conditions as I want, okay? In order to evaluate multiple conditions in one time, okay? And if none of these conditions are met, then finally I'm going to jump to the else condition. Yeah, here you have the logic explained. If the condition 1 is true, the statement of the block, statement block 1 will be executed. If not, condition 2 will be evaluated. If condition 2 evaluates to true, statement block 2 will be executed, and so on, so on, so on. Okay? So, at this point, we are going to jump straight to this exercise. Okay? So, in this case, I'm going to give you 5 minutes, okay, to see if you can create this program, because I don't want to give everything. I feel like this is a pretty important point of Python. So I'm going to give you 5 minutes. No, less, 3 minutes, until 15, okay? I'm going to give you 5 minutes to try to create this code by yourselves. Test_if.py, okay? So create this program here inside the robot control folder, test_if.py, and try to create a program which follows this logic, okay? Which follows this logic. Is there a wall less than 1 meter in front of the robot? Yes, then stop the robot. No, then keep moving. In both cases, print the reading, okay? Try to do it and try to not look into the solution which is down here, okay? I'm going to give 3 minutes so that you can try to do it by yourself, all right? Then the behavior is going to be something like, you are going to see something like this in the behavior. Try to do it and see what happens. Right, I'm back. And time has passed. So let's see what we can do here. Okay, so what we want is to apply this flowchart with this behavior, with this logic, into a Python script, right? So this is going to look something like this. Okay, let me close all this already. Okay, so we start by importing our robot control class and creating an instance of the class, okay, as always. Then what we need to do, we are going to need to get the laser reading, which is in front of the robot, right? Because we are evaluating this condition. Is there a wall less than 1 meter in front of the robot? So we need to know the laser reading right in front of the robot, right? So we need to get this laser value. And we store it in this variable named A, okay? Then we evaluate if the value is less than 1, then we are going to call the stop robot function. Else, so if this value is higher than 1, then I'm going to move straight, right? Then here I'm using these two new functions that we have introduced, stop robot and move straight, okay? Well, they are self-explanatory with the names, but you have also the explanation here, okay? So basically the move straight function is going to move the robot straight, and the stop robot function is going to stop any robot's movement. Then if else, and finally, for both cases, we print the value, okay? So, what is going to happen if I run this program? Let's do it. Test if. Okay, the robot starts moving forward and it crashes against the wall. Okay, so the robot is not stopping. Why? Can somebody tell me why? Why the robot is not doing the expected behavior? Because we would expect that the robot would stop when it's closer than 1 meter, right? What is the problem we have in our code? Reaction time? No, not really. Put it in a while loop. Okay, yeah, that's the solution. That's the solution to our problem. But the problem is that we are only evaluating our condition one time, right? When are we evaluating the condition? At the beginning of the program. When we evaluate the condition, the value of the laser reading is 2.5. So it's higher than 1, so I start moving the robot straight. But after that, I'm not evaluating again this condition. So the robot is going to keep moving straight because I'm not evaluating this condition anymore. Right? You see the problem? Read only once laser. That's it, Nikjos. You are right. So we are only evaluating the condition one time. So in order to actually have the behavior, actually I don't know what I did here. So in order to actually have the behavior of stopping the robot, what I would need to do is to continuously be evaluating this condition, right? Then for this, we have to introduce loops, okay? So with a loop, our behavior logic would look like this. Is there a wall less than 1 meter in front of the robot? Yes, stop the robot. That's it. if there is a wall in front of the robot, then I'm going to stop the robot. If no, then I'm going to keep moving the robot and I'm going to evaluate again my condition. Okay, now there is not a wall in front of the robot, so I will keep moving. And now, is there a wall in front of the robot? No. Okay, and now? And now? So basically these loops allows us to do this, to evaluate an statement continuously, repeatedly. All right? Then this can be achieved with loops. Then one of the loops we have, basically we have two loops. One is the while loop and the other is the for loop. Okay? So let's start with the while loop. Then while loop is going to work like this, okay? So we can start with a variable counter which is 0, okay? Then while this variable is lower than 10, while this condition is met, this is going to be executed repeatedly, okay? So at this point, in the first iteration, counter is 0. So counter is less than 10, yes. Okay, then I'm going to increase counter by 1. I'm going to print the value and I'm going to come back again. Okay, now counter is less than 10. Okay, then in this second iteration, the counter value is 1. So it's still less than 10. Then I'm going to go inside again. And so on, okay? Until the counter value, which has been increased repeated times, is 10. Then when this counter variable is 10, this condition is not going to be met. Counter is not going to be less than 10. It's going to be equal, in this case. And then I'm going to jump outside the while loop. Yeah? So basically, if I run this, I'm going to see something like this. I'm going to be printing the counter value from 1 until 10. Because when the counter value is 10, then I'm going to go outside. I'm going to go outside the loop. Okay? So this is a very simple example of how a while loop works. So what we are going to do here is to modify our code in order to include this evaluation. Okay? So how can I do this? Very easily. We have the code here. So let me actually copy it here. New file. Test while.py. There we go. Okay, so basically the program is pretty similar, okay, to the other one. So we are starting exactly the same way. We import the raw control class, we create an instance of our class, and we get the laser value of the front of the robot. Yeah, so we are starting, these 3 lines are exactly the same. But then I'm going to use a while loop. So while the value A is higher than 1, I'm going to be moving the robot straight, and I'm going to get again the value of the laser in front of the robot. So this way I'm going to update the value of the variable A, okay? Here I'm not evaluating again, and I am not updating at any point the value of the variable A, right? I'm not updating it. So I need to update the value of the variable with the new value, because as I am moving my robot straight, this variable, so the value of the laser in front of the robot, is going to be modifying because I am moving the robot. So I need to update this value. This is what I am doing right here. And I'm going to be printing it, okay? I'm printing here the current distance to the wall at every iteration. Then when this condition is not met, so when the variable A is lower than 1, then I'm going to go outside the while loop, and then I'm going to stop the robot. Okay? So let's try this new program with the while loop. For this, I'm going to reload the simulation to bring it back to the original position here. Okay, you can do this with this middle button in order to reset the simulation. This is going to bring the simulation to the initial status. Okay, and now I'm going to run the test while. So now we are going to see how the robot starts moving forward. The value is updating, and here, when the value has gone under 1, the robot has been stopped and it has not crashed against the wall. Okay? Yeah, so far so good. Does this make sense to you? Yes, okay. Done. It went till 0.5. Is it because of the time step? Yes, exactly. Yes, Krishna, it's because of the time step. Okay, so at what rate does rate function at? If I'm not wrong, all this is rating more or less at 1 per second. Yeah, we can confirm this here in this inside this code to check the rate. Yeah, so it's 1 hertz. Okay, so basically this is going to be evaluated more or less once per second. Okay, that's why it's not super precise. Yeah, if we evaluate this, let's say 10 times per second, then this is not going to happen. The robot is going to stop much faster when it goes down 1 meter. Yeah, so probably it would stop at 0.95 meters or something like that. Yeah. So this offset, it's because of the time step here. Yeah. So they are rating at 1 hertz, which is quite high for this. It's a low rate for these cases. Okay. So it would be much better in this case for the performance to use a higher rate, a 10 hertz rate or something like that. Okay. Then, yeah, so let's keep moving forward. Then we have the for loop. Okay, I'm not going to show this one. Basically, it's a different way of creating a loop. Okay, you can see here examples also, and you can do some exercises with the for loop in order to test it. Okay, but I'm going to leave this for you as homework so that you can check and complete these exercises. Okay. Okay, so interruption of loop iteration. Okay, we have two commands, two special functions, let's call them like that, which are break and continue. Okay, we can use these special functions in order to go outside while loop at any point. Okay, you can check this here also, how to use break and continue. I'm going to skip this also because I think that the most important part is done. So these are extras so that you can check them by your own. So let's move to next unit, unit for functions. Okay, let's move to this unit, which is super important and we don't have much time left. So let's move to unit for functions. When you change to unit 4, you are going to see that the simulation is going to change also, okay? So don't worry because it's normal. So it's going to load a new simulation. Okay, there we have it. All right, so now we have the super nice Summit Excel robot from Robotics. So for this unit, we are going to be working with this robot, okay? You are going to see also that the environment has changed. We have now this bigger space, okay? All right, so functions. Functions are also another super important part of any programming language. Not only Python, but of course also in C++ and others, right? So functions basically are used in order to first organize the code, and second, don't have to reuse code to don't have to write the same code multiple times. Yeah, so functions are used to reuse code. When there is something that I know, when there is some piece of code that I know that I'm going to be using very often, then I can encapsulate this code inside a function so that I can reuse it as many times as I want. Yeah? So, in order to define a function, we are going to use this structure, always, okay? Def of definition, def, the name of your function with parentheses and 2 points, okay? Like this. And then, again, inside the function, with the proper indentation, as you can see here, we put the contents, all the code we want to put inside our function. All right? This is for defining the function. Then, in order to activate a function, to activate the code inside the function, we need to call this function. Yeah, this is known as calling a function. Basically, this is what we are doing here. Here we are calling a function. Okay? So, in order to call a function, in this case, we do it like this. Yes? So we put the name of the function. Okay? Then, what else? Functions can have parameters. Okay? Then, if we want to define a function with parameters, we are going to put them inside the parentheses. Okay? So for instance, here, let me make this bigger. Here I am defining a function named add, which is going to use 2 parameters, a and b. Okay? And then inside the function code, I'm going to use these parameters as I want. In this case, I am just adding them. Yeah? And then, when functions have parameters, I need to pass these parameters when I call the function. Okay? So here I am calling this add function, and this function is expecting 2 parameters. So I need to pass them to the function, right? So now when I am calling this function, I am assigning the value 2 to the parameter a, and I am also assigning the value 2 to the parameter b, right? So if I run this code, I'm going to be printing the result, which is a plus b, which is 2 plus 2, which is 4. Right? Also, I can give default values to parameters, okay? So when I define a parameter, I can assign a default value, so that in case I call this function without passing the parameters, as you can see, then the function is going to take the default values for the parameters, okay? Okay, and as you can see here, I am calling the function directly. Why? Because this function is defined right here. So I can call it directly by its name, okay? In our case of the code, we need to call it through the class that has this function, okay? That's why we are calling it like this. We first put the instance of the class, which is RoboControl, dot, and then we call the function. And we are passing a parameter, of course, as you can see here. Yeah? We are passing this. So this getLaser function is expecting 1 parameter in this case. Okay? Then let's come back here and do this exercise. Create a function that, given an integer number, makes the robot move straight for that amount of time. For instance, if the given number is 5, the robot will move straight for 5 seconds. Then here we have an extra note for this exercise. You can use the Python sleep method. In order to use it, you just have to import the time module and then call the sleep method like this. Okay, this basically is going to stop the flow of the program for 5 seconds. Yeah. So let's create this program. Let me create a new script here, which I'm going to name test function.py. And then I'm going to paste, again, the code directly here from the solution and analyze it. Okay, there we go. So what are we doing here? As always, we are importing the robot control class, and we are importing time, in this case, which is another Python module, as suggested here in the exercise, okay? So that we can use this time sleep method, all right? Then I am creating an instance of the class. In this case, I am passing an extra argument also. Yeah, so this is an argument. As you can see, when we initiate our class, we are also expecting this robot name argument, which by default is going to assume it is turtlebot, okay? So if we instantiate this class without passing any argument here, this is going to take as default the turtlebot value. However, here we are providing this argument, as you can see. So we are changing it. Yeah, this is just we are warning here that we are using a different robot, so that some functions are going to be different. Okay, only for this. Then we are defining here our function. The name of the function is move x seconds, and our function has one argument, which is sex, in this case, seconds, okay? Then inside my function, basically I am calling the move straight function, first of all, so that I start moving the robot forward. Then I do an sleep for the specified number of seconds in the argument, and then after this time has passed, I stop the robot. So for instance, here I am calling my function with the argument, I am passing a number 5. So in this case, the seconds argument is going to be 5. So I'm going to start moving the robot straight, then I'm going to sleep the program, so the program is going to stop here. Let me add a comment here. Program will hang here for 5 seconds. In this case, it's going to hang. The program is going to hang here for 5 seconds because I am specifying this number. I am passing this number as argument. And then after these 5 seconds, I'm going to call the stop robot function so that the robot is going to stop. So what I expect to happen here by calling my function is that the robot will start moving straight, moving forward for 5 seconds, and after this time passes, the robot is going to stop, right? So let's test it. Let's come here again to the robot control folder and run, in this case, the test function script. So we see the robot starts moving forward for 5 seconds, and when the time passes, the robot stops. Okay? Yeah? So far, so good. What is self? Does it mean function self parameters or class-related self parameters? Class parameters. Yeah. So this is you are going too fast because you are going to the unit 5. Yeah. But basically, self it means the class itself. Yeah. So here it means that I am going to be able to use the class attributes and the class elements by using this self, okay? So self basically contains the class itself. Class parameters, as TSEDL is saying, is the whole class. Are class parameters, class methods, class attributes, everything. Yeah, so it's basically the class itself. Okay, so the return statement. So most of the functions are going to return something, okay? So that it can be used somewhere else. So for instance, here we have the same function as before, but using the return statement, yeah? So basically I am defining the function at, I am doing the operation, but instead of printing here, as we were doing before, here we were printing, what we are doing here is to return this variable, okay? So what is going to happen now? That when I call my function add here, I'm going to have to store the returned value in a variable, okay? So what is going to happen here is that I'm going to call this add function with the arguments 3 and 4. So I'm going to do this operation, 3 plus 4 is 7. Then I'm going to return the 7 value, which is going to be stored in the variable r, okay? So at the end I'm going to print the variable r, which is going to contain the number 7, right? Let me run this code, and here you have it, okay? So this is the most common structure when working with functions, okay? So usually you are going to be returning something so that it is used somewhere in the code, okay? So this is the most common case, so keep this in mind. What else do we have here? Okay, yeah, so a function can return exactly one value, or we should say one object, okay? So an object can be a numerical value, like an integer or a float, but it can also be a list or a dictionary, okay? So we can return one value, like we are doing here, but we can also return a list, for instance, or we can return a dictionary also, yeah? So if we have to return, for instance, 3 integer values, we should return a list or a tuple, of course, with these 3 integer values, okay? So we cannot, for instance, do this. Return 1 and or return 2 then down here, okay? So, or we cannot do return 1 and 2 and 3, okay? So in case we want to return multiple integers, we should use a list in order to do so, okay? All right, so okay, yeah, so some exercises here for the return. And local and global variables in functions. Okay, so I think I'm going to leave it here so that you are going to finish by yourself, because we are already on time. So let me have a quick look at the chat. Any questions so far? Do you have any question that you would like to do before I finish the class? Related to functions, or let me know now, or shut up forever. Just joking, just joking. Okay, I don't see anything in the chat so far. Let me refresh, because now I'm not sure if this is freezed or not. No, it's not freezed. Okay, then all right, then I'm going to finish my class here. So as I said at the beginning, will there be any short introduction to autonomous vehicle simulation with ROS2 anytime in the week? No, Krishna. Unfortunately, there's not time for that. So we are going to be introducing basic concepts of ROS. Okay, so how to create packages, how to create programs, compiling, ROS2 topics, etc. But we are not going into autonomous vehicles. How to reset the simulation point of view? That's a good question. In fact, in order to reset the simulation point of view, I think you are going to have to restart the simulation. Because like this, it's not done. It's only resetted the positions and everything. So you are going to have to reload the whole simulation. If you want to reset the point of view, you are going to reload the whole simulation, which I don't recommend. So better that you move around the view so that you get the exact view that you want. Because reloading the whole simulation, it's not a very good idea. So just move around, okay, so that you get the view that you want, okay? At the beginning, it can be a little bit complicated to get used to it, but once, with some practice, you are going to see that it's super fast to move to things and move around and change the view and whatever, okay? Would you go into object-oriented programming part? No, unfortunately, we don't have time for that. So you are going to have to go there by yourselves, okay? However, don't worry. You can, as I was saying at the beginning, you can continue with the course now by yourselves, okay? So basically, I am not. What I am doing basically here is to follow all the explanations that are here in the notebook. In fact, I am in the notebook, it is better explained, okay? So you can just go to the object-oriented programming part and start following the notebook, okay? Here you have all the explanations, you have all the exercises, all the solutions, so you are not going to have any problem, okay? In case you have any problem, in case you have any doubt, you can click here in the question mark icon and go to the forum, okay? And then here you can create a new forum and say, hey Alberto, or hey the Construct team, I don't understand this. Can you explain to me? Or I am having this problem, whatever. And then we are going to answer you here in the forum, okay? But don't worry, because you have everything explained here. So don't be afraid of going by yourselves, okay? You can go now that I'm going to stop with the class. You can do it tomorrow morning if you want, or you can review it next week, okay? So this course is completely free, so you can access it whenever you want, all right? So don't worry about that. Okay, so yeah, I'm going to leave it here. So let me switch my view. So thank you very much, all of you, for being today with me here, being one more day with me in day 2 of the ROS2 Learning Week. So I'm going to see all of you tomorrow, Wednesday, in day 3 of the ROS2 Learning Week. And tomorrow we are going to actually start with ROS2. Okay, so try to be prepared, because we are going to start learning ROS2 concepts, creating ROS2 packages, creating our first ROS2 programs. So be prepared for today, because we are going to start with the core of this week, with ROS2. All right? So yeah, nothing else from my part. Thank you very much for being here with me and for the feedback you are giving me in the chat. And yeah, I will see you tomorrow. So until then, take care and keep pushing your learning. Bye-bye.
What are you doing, Alberto?
I'm training this intern with ROS.
Oof! Did you have the same experience? Spending too much time equipping your team with ROS skills? Check out our ROS Online training solution for enterprises. A fast and easy way to empower your team with ROS. From ROS basics to manipulation, perception, AI, ROS2, everything your team needs to learn is here. Practice with real and simulated robots. Train your team by doing from day one. Also, our ROS experts will provide you 1 hour of consulting services to boost your robotics projects. Want to become a happy Alberto? Request a demo today.